So you've got they're asking for the formation of solid iodine trichloride, right? So uh, enthalpy change of formation, iodine trichloride solid. So 1 mole of this has to be formed from its constituent elements. Okay? The enthalpy change of the formation is that it's going to form from its elements. The elements are I2 and 3Cl2. Let's make it 2ICl3. I don't want to go into fractions again. As a Cl2 is a gas, and this one is a solid. So this is enthalpy change of formation is for 1 mole. I'm doing it for 2 moles. So I want to find 2x instead of x. Okay, that is the unknown that I want to find out. Just didn't want to go into fractions, so that's why I'm writing this. Okay, ye clear? Is this part clear to this point?
Yes, sir.
So next thing is I've got 2 reactions. I'm going to use those reactions and connect them with this one. Okay, so for example, the first one, yes, Abdullah.
Sir, I'm sorry, but I did not understand why is it 2x.
नहीं वो था कि enthalpy change of formation is for how many moles of ICl3? 1 mole, right? Sorry. Yeah. It's for, so the actual equation that they want us to find out is this one. It's half 3/2 and 1 mole of ICl3. So basically they want us to find what X is, right? The enthalpy
Right.
change of this reaction. Well, but I just don't like fractions, TK, which is why
I see.
why I'm just multiplying everything by 2. So I'm trying to find out double the amount, TK.
Right.
So I'm trying it for 2ICl3, so this would become 2x, TK. So I'm trying to find 2x. So basically Hess law is one path is equal to the other path. So I just need to figure out what this other path is. Okay, so if the enthalpy change of this other path is found out, I'll be able to figure out the enthalpy change of this particular path. What you're going to do is you're given 2 reactions. First one, iodine reacts with Cl2 to form 2 ICl. So one iodine reacts with 1 Cl2. So one iodine reacts with one of the Cl2s to form what? To form 2 ICl solid. And the enthalpy change is plus 14. So we are talking about the first reaction. So remember, one iodine reacts with 1 Cl2, one iodine reacts with 1 Cl2, just one, to form 2 ICl. So that means 2 of the Cl2s are still left. They didn't take part in the reaction. Okay, so the first reaction, again, I'm going to repeat. One iodine reacts with 1 Cl2 to form 2 ICl. One iodine reacts with 1 Cl2 and to form 2 ICl. And 2 of the Cl2s are left. Okay, is that clear? P plus 14 and that's plus 14.
Yes, sir.
And then you've got the other path, which is the second reaction. ICl reacts with Cl2. In our case, it's 2 ICl reacts with 2 Cl2. So we've actually doubled that. 2 ICl reacts with 2 Cl2s to form 2 ICl3 solid, right? So it's this path. This one over here. So we've got 2 ICl reacting with 2 Cl2s to form 2 ICl3 solid, and the enthalpy change for that would be also multiplied by 2. It's going to be minus 88. And it's going to be times 2. So we've created the cycle now, and one path is equal to the other path. So that means this path is equal to this path. So that means 2x is equal to plus 14 and minus 88 times 2. Okay, 2 ko hata do, so that's this. What do we get for this? Minus 81.
Yes, sir.
So we're getting minus 81. Is that clear?
Yes, sir.
So then, so we're not going to do this one yet. Just 1 second. So now, and there's this other one as well, which is, so we'll do that later. Let's move on to the formula now. Okay, just remember Hess law works. Okay, just remember there'll be very few questions on the Hess law. Most questions would be solved using a formula, and we're going to move towards that formula now. And the formula is really basic. Okay, how to solve? I mean, this thing is really basic. It's like it makes things very, very, very easy. So let's. Okay, this whole drawing the cycle thing was difficult. So the formula is simply this. If you're given a reaction, any reaction, so I've got my reactants and they're turning into my products. And the data that's given is that they've given me the enthalpy change of formation of my reactants. And they've given me the enthalpy change of formation of my products. Then it's a simple formula, which is that the enthalpy change of this particular reaction, this one over here, the enthalpy change of this particular reaction is the enthalpy change of formation of my products and minus the enthalpy change of formation of my reactants. That's the simple formula. And I'm going to do some questions on this, just to show you. I'm going to draw the Hess cycle and then I'm going to use the formula. And I'm going to explain how the formula works. So let's try and open the other worksheet now. जो formula वाली है, that's so we've got ये वाली है, Hess cycle formula. And just give me 1 second. So let's try with the first question. And I'm going to try and do this both ways. I say first question. Now, what is he asking for? He's asking for. I'm going to draw the Hess cycle first. So now he's asking for you to figure out the enthalpy change of combustion of ethanol. So I'm going to write down the reaction. Okay, this reaction, he's asking you to ethanol is C2H5OH, and he's asking for the enthalpy change for its combustion. So you burn it, oxygen, and it's going to produce carbon dioxide and H2O. And there's going to be 2 carbon dioxides, and there would be 3 water molecules. And 4, that's 3 oxygens, right? This is a liquid. This one over here is a gas. You got another gas. and this one is a liquid, right? So he's asking you to figure out the enthalpy change of this reaction. So what did the Hess law state? The Hess law stated that if you can come up with another path, you're going to start at this point, and if you can reach the other place, if you can create this other path, the enthalpy change of this other path would be exactly the same. So we're going to try and create this other path. I said, what have they given us? What information do we have with us? They've given us the enthalpy of formation of carbon dioxide. So I'm going to write down the reaction. He's given us the enthalpy of formation of carbon dioxide is this reaction. That 1 mole of carbon dioxide is produced from carbon and oxygen. They've given me the enthalpy of formation of water. That's also given. So enthalpy of formation of water is that 1 mole of water is produced, and it gives you 1 mole of water. And they've also given me the enthalpy of formation of ethanol. That ethanol being formed from its elements, that's 2 carbons plus ethanol, that's 6 hydrogens, that's 3 H2s. And you need oxygen as well for ethanol formation, that's half O2. And together they will form C2H5OH. So we've got this. And let me just double check this. Okay, that's fine. So given me the enthalpy changes of all these 3 reactions, and I'm going to try and create this other path. Okay, so so let's start over here. So what they've given me is that they've given me that the amount of energy required to form carbon dioxide and water from its elements. Like if I want to form carbon dioxide from its elements, that's so that requires 2 carbons plus how many oxygens? 2 oxygen gas molecules. Okay, so what is the amount of energy that is required to form 2 moles of carbon dioxide? That's given over here. That's given as E minus 2 minus 393. Okay, that's so that one is minus 393 kilojoules per mole, and times 2 because I'm forming 2 moles of carbon dioxide, right? Is that clear?
Yes, sir.
Abdullah, clear? Similarly, we've got water as well. So the amount of energy required to form 3 moles of water. So for that, you would need, if you look over here, that's you need hydrogen and oxygen, right? You need 3 moles of water. So 3 moles of water would be formed when you need kitne hydrogens honge? That's going to be 3 H2s and 3/2 O2 gas molecules, right? And for that, the amount of energy would be minus 286 and times 2, right? So I've written them together in one step. Okay, you get the elements together, and so I've written them in one step. Okay, 2 carbon dioxides forming from its elements, 3 water molecules forming from its elements. This is the amount of energy that would be required for that, and this would be multiplied by 3, not 2. So that's going to be multiplied by 3. Then they've also given me the enthalpy of formation of ethanol. That's to form ethanol, you need 2 carbons plus 3 H2, so you can go in this direction. If you want to form ethanol from its elements, so 2 carbons plus 3 hydrogens plus half oxygen over here, that's that would do its job. You'll still be left with 3 O2. So that's forming 1 mole of ethanol. And the energy required for that is minus 270 7, and you're only forming 1 mole of ethanol. Okay, so my cycle is complete now. I've figured out this other. I've created the cycle now. Okay, clear है ये?
जी sir.
And since I have the cycle now with me, it's all I have to do is one path is going to be equal to the other path, which is, so I've got my one path, and that one path would be equal to my other path. So that means my enthalpy change for the reaction is going to be, इसका sign change करना पड़ेगा. I have to go in this direction. So this would be plus 277. And this other one would be, that sign should not change because it's in the right direction. So it's going to be minus 393 times 2 and minus 286 times 3. So I'm not going to do anything over here. So that is the path that I'm looking for, and that will give me my answer. What's the answer to this, by the way?
Sir, option B.
Minus 1367. Okay, so we're getting minus.
Yes.
Kilojoules per mole. Now what we're going to do is, I'm just going to repeat this one more time. Okay, they gave me the formation of carbon dioxide, so I formed carbon and oxygen forming carbon dioxide, hydrogen and oxygen forming water, and they also gave me the formation of ethanol. So carbon and hydrogen, all of them got together to form ethanol. So one path over here, one path over here. I knew the enthalpy changes of all of them, and I created this other path. I said, now I'm going to do the formula. Remember, drawing the Hess cycle took a long time, right? And it was confusing as well. Now the formula is going to make things easy. So this is the formula. We have this reaction, the enthalpy change of combustion of ethanol. They want us to figure out the enthalpy change of this reaction. So the data that they have given us, right? This is the enthalpy change that they're looking for. And the data that they have given us, they've given us this data that they've given us the enthalpy of formation of ethanol, right? You don't need to write the equation. That's the information that they've given us. They've given us the enthalpy of formation of carbon dioxide, and they've given us the enthalpy of formation of water as well. And the enthalpy of formation of water is 0. Remember, elements, elements don't need to be formed. So their enthalpy of formation is 0. So I'm going to plug in the data. This one was, I think, enthalpy of formation of ethanol was minus 277. Enthalpy of formation of carbon dioxide was, I guess, minus 393. And enthalpy of formation of water was minus 286. So
not multiplied by 2.
वो मैं करता हूँ. So it's going to be multiplied by 2. So all you have to do now is, because enthalpy of formation is for 1 mole, right? You have 2 moles of carbon dioxide. So the formula, what is the formula? This is how we're going to use the formula. Forget the equation, don't write the equation, don't do all the working, etc. The answer is going to be direct. So what was the formula? The formula was that the enthalpy change of this reaction is going to be the enthalpy of formation of the products minus the enthalpy of formation of your reactants. That's it. So the product enthalpy of formation, that's your product enthalpy of formation. So start plugging that in. I'm going to put a bracket around it. It's minus 393. That's my product. But I'm going to multiply it by 2 because that's 2 carbon dioxides. Enthalpy of formation of water, that's minus 286, and there are 3 water molecules that you're forming. And minus the enthalpy of formation of the reactants. So the reactant enthalpy of formation has to be subtracted. So it's going to be minus 2 7 and the other one is 0. ठीक है, इसका याद रखना है कि enthalpy of formation of elements is always 0 because you don't need to form them. So anyways, you got this, and once you have this, you just solve this, you're getting exactly the same expression, and you'll get minus 1367. So this is very simple, but it is conditional. Conditional ye ke you have to know the enthalpy of formation of the reactants and the enthalpy of formation of the products. Only then will the formula work. So you just have to do product minus reactants, and you'll get the answer to your question. Okay, is the formula clear? You don't need to draw the Hess cycle. So is this formula clear, this one?
Yes, sir. Sir, can you show the example where the formula is not applicable?
The formula is only applicable if you know the enthalpy of formation of products and the enthalpy of formation of the reactants. जिस तरह अभी हमने जो questions दी किए थे, most of them were not about where we did the drawing Hess cycle, right? So for example, over here,
Yes, sir.
I mean, this equation is not the enthalpy of formation. This equation is not the enthalpy of formation, right?
Yes, sir.
So which is why we had to draw the cycle. Same goes over here. Like this is not the enthalpy of formation. Water gas turning to water liquid is not the enthalpy of formation. So there was no choice. You had to make the cycle. Okay.
Okay, sir. Okay.
There's another version of this formula which is exactly the same. You do exactly the same, but that's related to enthalpy of combustion. And everything is kind of exactly the same. Okay, so what if you have a question, and in that question, so let's put it over here. And so now in this other one, so now in this other one, what is given is instead of enthalpy of formation, you're given the enthalpy change of combustion of the reactants as well as the product. Now in that case, the formula is that you take the enthalpy of combustion of your reactants and you subtract them from the enthalpies of combustion of your products. So it's kind of the opposite now. So there are two types of questions that will be asked. One in which the enthalpies of formation of the reactants and products are known. The other one in which the enthalpy of combustion of the reactants and products are known. दोनों में formula उल्टा लगेगा. And remember, the formula is dependent on the data that's given. The equation is irrelevant. Whatever the equation is, we don't care about the equation. We don't care what the reactants are. We don't care what the products are. We don't care what the equation is. As long as it all depends on the data that's given. If you're given the enthalpy of formation of the reactants and enthalpy of formation of the products, use this formula. If you're given enthalpy of combustion of the reactants and enthalpy of combustion of the products, use this one. Okay? Clear here? We'll start doing questions now.
Sir, same goes for the visualization.
There's no formula for that. And also remember, in enthalpy of combustion, when we did enthalpy of combustion, I told you that enthalpy of combustion of things that have already combusted, their enthalpy of combustion is 0. Like carbon dioxide, enthalpy of combustion would be 0. Because burning carbon dioxide with oxygen will produce carbon dioxide, which means you didn't do anything. Burning water, so enthalpy of combustion of water is also 0. You can remember that. So let's try and let's try and do the formula questions. Starting with this one. Ignore. Remember this thing. People get confused with the equation. Ignore what the equation is. You don't care what the equation is. All you care is what is the data that's given. So you're given the enthalpy of formation of H2S That's minus 21. You're given the enthalpy of formation of H2O liquid, that's minus 286. And you're given enthalpy of formation of SO2, that's minus 297. And enthalpy of formation of oxygen is 0. Okay, or so which formula, product minus reactants? The enthalpy change of the reaction would be equal to the enthalpy of formation of what? Products minus your reactants. So product minus reactant, minus 286 times 2, that's my product. Be careful with the signs. You get minus 286 times 2. Then you have minus 297 times 2. And minus your reactants, which are minus 21 times 2. And the other one is 0. I said it's better to put things in brackets because you don't want the signs to get messed up. Products minus reactants. So this would turn into positive. So what do we get for this?
Option B.
B?
Yeah.
So the excess can be marked right now. That's the next one. You look clear, na, ye wala.
Yes.
So the next one is again, what is the enthalpy change of combustion of methane? Remember again repeating. What is the equation? Combustion of methane. That's burning methane, CH4, reacting with oxygen, producing carbon dioxide and 2 water molecules. And again, I repeat, this equation is irrelevant. What is the data that's given to you? You're given the enthalpy of formation of carbon dioxide, that's minus 394. Equation jo marzi ho, equation, whether it's combustion, whether it's neutralization, whatever it is, we don't care about the equation. All we care is what is the data that's given. So carbon dioxide minus 286 for this one. And we've got methane enthalpy of formation, which is minus 74. And this one would be 0. So product minus reactants, right? So enthalpy of the reaction would be equal to product, which is minus 394 and minus 286 times 2. Minus reactants, which is
So option
option.
A.
Okay, we're getting A for that. As if the next one is same exact. Formation of all three are given. Magnesium nitrate, that's minus 696. MnO2, that's minus 520. And this is 33. So again, product minus reactant. So the enthalpy of the reaction will be minus 526. 520, sorry, 520. And plus 33 times 2. And minus the reactant, which is minus 696. Kya bana hai? What do we get?
Positive 28. Sorry, 242.
Okay, so we're getting positive 242. So now, sometimes they're going to trick you with questions like these. For example, he's asking, use this information. What is the enthalpy change of combustion of propanone, which is this one? So combustion of propanone, that's C3H6O. Combustion would be, it reacts with O2. produces and 3H2Os. 3H2Os, right? So that's 6 plus 3, 9 oxygens. So यहाँ पे there's going to be 4 O2s, right? So what is the data that's given to you? That's they've given you the enthalpy of formation of propanone. So this is given. I said now minus 254. Now we have a problem. Remember, the formula only works either you know the formation of everything or you know the combustion of everything. यहाँ पे they've given you some mixed data. So what do you do over here? Like if I were to apply the formula for formation, I would need the formation of propanone, but I would also need the formation of carbon dioxide, and I would also need the formation of H2O as well. But they didn't give me the formation of these two things. Can I still apply the formula? So what is the...
No.
So you can't really... So remember this, the formula only applies in an equation, you know all reactants products, all their formations, or you know all their combustions. ये mixed वाला काम नहीं चलेगा, ठीक है? You can't have both things. So what is combustion of carbon, by the way? It's carbon plus oxygen forming carbon dioxide. Can I call it the enthalpy of formation of carbon dioxide?
Yes, sir.
Okay, it's exactly the same thing. Okay, so remember we did discuss this when we were talking about definitions. The enthalpy of combustion of carbon is the same thing as enthalpy of formation of carbon dioxide. They both represent the same reaction. Similarly, the enthalpy of combustion of hydrogen, enthalpy of combustion, this is combustion of hydrogen. But it is also the formation of, or equivalent to the formation of water. So it's exactly the same thing. So although they did write formation, but they actually gave you that information. So the enthalpy of formation of carbon dioxide is given, that's minus 394. And they've also given you the enthalpy of formation of water as well, that's minus 286. You can remember sometimes the same enthalpy change can have multiple labels. Or even a zero. So you're going to do product minus reactant. So the enthalpy of the reaction would be products minus 394 times 3. And minus 286, that would be times 3. And minus your product minus reactants. Minus your reactants, that's minus 254. क्या बना?
Option C.
So this one is option C. Similarly, we've got, let's try and do some combustion questions, this one. In this case, they gave you the combustion, enthalpy of combustion of carbon. So minus 394. And they gave you the enthalpy of combustion of hydrogen, that's minus 286. And they gave you the enthalpy of combustion of butane, which is minus 2877. So what was the formula for the enthalpy change if you're using combustion? So that's reactant minus products. So reactant is minus 394 times 4, minus 286 times 5. So enthalpy of combustion of reactants minus enthalpy of combustion of the product, which is minus 2877. क्या है?
Option or B.
Okay, that's B. So then you'll have questions where one of the middle, the answer would be given and the initial thing would be missing. For example, you're saying a student calculated the enthalpy of formation of ethane, right? So that means 2 carbons reacting with 3 H2s forming C2H6. So he's saying they wanted to find out the enthalpy change of this reaction, formation of ethane, using a method based on the enthalpy of combustion. So data would be given on the enthalpy of combustion of everything. He used correct values for the standard enthalpy change of combustion of ethane. So ethane. So this is minus 1560. Enthalpy of combustion of hydrogen, that's minus 286. But he used an incorrect value for the standard enthalpy change of combustion of carbon. So I'm going to take that as X. They didn't tell me. They said that it's an incorrect value. They then performed the the calculations correctly. And the final answer was minus 58. So they actually figured out the final answer, which was minus 58. So we're going to try and figure out. So the answer is already with us, enthalpy of reaction. That's minus 158. How do you calculate that? Enthalpy of combustion of the reactants minus enthalpy of combustion of the product. So it's going to be 2x. So that's my reactant minus 286 times 3. So enthalpy of combustion of my reactants minus my enthalpy of combustion of product. So that's minus 1560. So you clear it all. The original data was actually missing. The final answer was already given to you. So you'll be able to figure out the original value. What do you get for X? Yeah, calculate.
Sir, option C आ रहा है मेरा.
Confirm it's C. See, it looks like C. Okay. But is this clear? I mean, these questions are very easy. Okay, is this clear?
Yes, sir.
Saro, most of these questions, they would be very straightforward. Simply, formation is given, formation. Product minus reactants, that's it. And most of the questions are similar to this, TK. So we'll practice more of them in the next class as well. And this kind of covers Hess law. We're done with Hess law, basically. Most of the questions are just these formulas. Combustion, reactor minus product, formation, product minus reactants. The drawing part is the difficult part. That's the only part that's difficult. So ठीक है, next time continue करते हैं, ठीक है?
Okay, sir. Sir, can you send this video and the last one?
मैं दोनों करता हूँ, ठीक है?
Okay.
Okay.
Allah Hafiz.